Hey there, welcome back. It's good to see you. Let's get into a couple more examples of separable differential equations. A little bit of a different algebraic take on these, but you're up for the task. So if you have yet to watch video 1 in this lesson, do it and then come here. But if you're ready, let's go. Find the particular solution y equals f of x to the differential equation, that's this, with the given initial condition. That's that. Okay, so again, we're going to separate variables. So what we do there is multiply both sides by y. That gets the y with the y's. And multiply both sides by dx. Multiply by dx. Technically not doing that, but it is the way it is taught by so many of your teachers, so I'm going to go with it for now. So we've got the x's together and the dy's together and the y's together. What I like to do is make sure that I have as much stuff on the x side as possible since we're solving for y. There's no sense in having any extra junk, so that's why the negative stays with the x. So now I'm going to integrate both sides. So integrating y with respect to y is y squared. Okay, over 2. Very nice. And then this right side is going to be minus x squared over 2 plus c. And as I stated in the first video, you only need to put plus c on one side, but you have to have that constant integration. If you don't have that there, serious points are going to be taken off, especially if you're taking the AB or BC exam. We don't need the c over here because a constant subtract from a constant is, well, constant. Okay, now at this point you can certainly plug in and solve for c, or you can solve all the way down. Your call. In the first video I didn't solve for c till the end. In this one I'll plug in now just to show you it doesn't matter. So I'll plug in 0, negative 4. So negative 4 gets plugged in for y all over 2, and that's equal to minus 0 squared. Okay, well, minus 0 squared. Don't know why I'm going all that effort. That's just going to be 0, and so that's going to be 16 over 2 is 8. That's 0, that's equal to c. Okay, so we plug it in exactly where we left off. So y squared over 2 is equal to minus x squared over 2 plus 8. Now we solve. We're going to solve for y. How do we know that we need to do that? Because we're told get y equal to f of x. I'm going to multiply both sides by 2. That's going to be y squared is equal to, the 2's are going to cancel here, plus 16. Again, that's multiplying both sides of the equation by 2. Now I've got to isolate this. I'm going to take a square root. But when you take a square root, there needs to be a plus or minus. We'll talk about that one shortly. The reason why there has to be a plus or minus is some number squared equals a number. So that number could be positive or it could be negative, and it's still going to end up being the same exact number. So how do we know which branch, the positive or negative branch, to use? It has everything to do with the initial condition. The only way we can get a negative 4 out is if we use the negative branch. So we'd have y equals negative the square root of minus x squared plus 16. So that's your final answer. If this had been a positive 4, we would have used the positive branch. Any number that comes out of the square root in the domain is going to be positive or 0. So if we don't have that negative out there, there's no way to get the initial condition of negative 4 when we plug in 0. That's why we pick the negative and not the positive branch. That's it. Very cool. Okay, let's do another one. Okay, this one. Lesson in this one. Find the particular solution to the differential equation with the given initial condition. It's as if I copied the same directions that I made. I did. So looking at this one's a little bit of a nasty one. It doesn't play fair. Instead of, well, first of all, instead of adding y to both sides, which you could, you're going to realize that if you add y to both sides, and we'll do that, something bad happens. Do you see how there's no multiplication at all? And so we don't have anything we can integrate yet. It needs to be y times dy so that we maintain the idea of area in that integral. That is wrong. So how do we separate the variables? Well, what we do here is a couple of things. What I like to do that you don't have to do is I factor out a negative 1 here. The reason why I do that is because now I have less stuff to bring over to the left side, right? So I now have that negative 1 that's going to stay on the side of the x. We're solving for y, so you might as well get as much stuff and leave it on the right side. It's going to make life easier. So now I divide both sides by y minus 1. Division allows me to then integrate it, and I'm going to multiply both sides by dx. That's negative 1 dx. Isn't that sweet? So it's a hard problem, even though it looks simple to start. So now that the variables have been separated, we integrate both sides. The integral of 1 over y minus 1 is ln of the absolute value of y minus 1. Nice. Way to go. That's equal to just minus x plus c. All right. So At this point, you could plug in -1 and 2. I'm going to solve for everything. So I'm going to exponentiate both sides to undo that ln. That's going to give me the absolute value of y minus 1. These undo each other. Equals e to the minus x, and then there's a c. I went over in the first video why there's that c. I'll go over it again here. These are now exponents. You have e to the minus x times e to the c. If we're adding exponents, you're multiplying the bases, and e to the c becomes that same constant. Now, to undo the absolute value, we would do plus or minus on both sides, or on the right side, but that gets absorbed by that constant c. Now, I like to write a new constant here so it's not that same constant. I like to put a k, but it's perfectly fine if you put a c there. And again, we're solving for y, so I add 1 on both sides. So that's c e to the minus x plus 1. All right, so that's our general solution. So now, all we have to do is solve for c. Let's plug in. So I plug in 2 for y. That's what it tells us to do. And that's equal to c times e to the negative x, or the opposite of x. We're going to plug in -1 for x, and then we're going to add on to that 1. All right, let's solve for c. So 2 minus 1 is 1. You get c e to the 1, it's just e. And so c equals 1 over e, or e to the minus 1 if you will. So we'll plug that back into this, and we'll be done. Y equals 1 over e times e to the minus x plus 1. And that's an acceptable answer on the A, B, or BC exam. That's perfectly fine. But if your teacher really wants you to, you could get all fancy-like and see that that's e to the minus 1. And when you have the same base, you can add exponents. So it'd be e to the minus 1 minus x plus 1. You don't have to go that far. This is perfectly acceptable. So is that. All right, that'll be it for this video. In the next video, we're going to go over a problem that asks you to state domain. I'm psyched for that one, but I was psyched for these too. Two very good problems. I'll see you soon. Peace.